Right, 2012 high level question 1, the drawing details. So we'll go through the question, we'll read through the question first of all to try to get an understanding of what's being asked, and we'll go from there. A triple glazed bay window projects 1.5 meters from the external wall of a dwelling house, as shown in the accompanying sketch over here. This will be helpful. The external wall is a 350mm concrete block wall with an insulated cavity. The lean-to roof is an insulated slated roof and has a pitch of 30 degrees. Insulated plasterboard is fixed to the underside of the rafters to form a sloped ceiling. To a scale of 1:5, draw a vertical section through the window, roof and front wall of the house. The section should also show the typical construction details from 400mm below the concrete lintels of the bay window, through the fixed frame of the window, wall plate and rafter, to a level 400mm above the abutment of the lean-to roof and the front wall of the house. And part B just asks to indicate on your drawing the design detail that ensures moisture does not penetrate the abutment of the roof and wall of the house. So probably a harder question than 2011. A little bit more to try and get your head around, and a couple of tricky words there which might catch people out. First of all, I just want to look at the sketch. These sketches can always be helpful in terms of visualizing what you have to do. What we have here is a lean-to roof. That roof there is a lean-to roof. It's a roof that leans off the side of a house. This window is what's called a bay window. If you ever see a house that has an extension part leaning out of the house or built out from the house, it's a bay window. These are standard windows. That's a bay window there. The abutment, which was mentioned there, is where this rafter, where this roof, it butts into that house. That's the abutment. So there's a bit of detail work that has to happen there where all the rafters of this roof hit that wall. That's the abutment detail. So essentially what's being asked there is we have to draw a detail 400mm below the window, up through the eaves detail, along that rafter and up through that abutment 400mm above there. So basically here, down, as far as there. Alright, so we'll have a look at the keywords in the question now, which will help us to fine tune that information as well. A triple glazed bay window, right, that's important, it's triple glazed, projects 1.5 meters from the external wall. Alright, so this is 1.5 meters distance there to there, which we need to know, of a dwelling house as shown in the accompanying sketch. The external wall is a 350mm concrete block wall with an insulated cavity. So a standard concrete block wall. No timber frame wall, it's a concrete block wall. The lean-to roof is an insulated, slated roof and has a pitch of 30 degrees. Pitch means angle. Insulated plasterboard is fixed to the underside of the rafters to form a sloped ceiling. So there's insulated plasterboard fixed to the underside of the rafters. We'll look at that at the very end of the question. It's a small little detail we have to add in. 1:5, very important. This is going to be quite a big detail. We're going to need a full A2 page to fit it in. Draw a vertical section through the window, roof and front wall of the house. This section should show the typical construction details from 400mm below the concrete lintels of the bay window, through the fixed frame of the window, the wall plate, the rafter, to a level 400mm above the abutment of the lean-to roof and the wall of the house. So 400mm below here, above through the wall plate, through the rafters, and 400mm above there is what it's asking for basically. Alright, now as we said, 1:5 means this is going to work out relatively big. You need to have your A2 page, turn to landscape, like we pretty much always do, to help us work through this one. Now I'll just get to position. For my sketch, I have an A4 page, so just try and visualize it that way. Bring this back a little bit. Right, I just indicated the bottom corner of my A4 page there to help you understand where I'm starting. I'm going to stay fairly low, come over a little bit, but leave a bit of space here so you can draw soffit and fascia. I'm going to start with the wall. We always say build up this drawing as if you're a builder building the house. You know, start with the wall and go from there. Now the window is going to be roughly along here. It says to go 400mm below the window head. That works out 80mm when scaled down. So I'd measure up a little over 80mm. Okay, whatever that may be, and I'm going to draw a line across there, and that's where I'm going to start my wall. All right, keep it fairly to the left, but leave a bit of room over here so you can draw in your fascia and soffit and gutter and all of that. And I'm going to start by building up my wall up along here. So the question says it is a 350 millimeter cavity wall. I'm going to lightly draw in those positions. And bear in mind, this is 1:5, so 300 millimeters, that is about 100, 150, and 100. All right, that's going to be 20, 30, and 20. So it's going to be quite big when you actually draw it down first of all. That's all done lightly first of all. I'll draw in my insulation. It says it's an insulated cavity. All being done lightly first. I'll probably be rubbing out a little bit of that. Above the window we always, there's a block by the way. Above the window we always have an extra bit of insulation as well. There, all done lightly first of all. I'm going to get my window drawn first of all. It doesn't specify the size of the window frame, so we're just going to go say 150 by 80, like the last question. That's kind of a standard size of a window frame or a door frame. 80 millimeters across 150 and 80 millimeters. There's a rectangular shape of my window frame. Measure in about 5 millimeters there, 5 there. That can vary depending on the window manufacturer. Measure down about halfway there and put the position of your window unit into place there. If you want to put a little angle there for a design, which we often do, go and do that. That all depends on the window manufacturer. Put an angle on that there. Okay, so the main size there is 150 by 80, and then just get the positions of the center for your window frame and all of that. It doesn't specify that it's a thermally broken window frame, but we'll just make it thermally broken because triple glazed windows usually would be. And our triple glazing, the width of a pane of glass, 1 or 2 millimeters. What I like to do, just for time's sake, is just estimate those positions. Have the middle one there and go down. The examiner's not going to be measuring the exact position of your window frame. As long as it looks like they're all about a millimeter or so thick and it looks like the middle one's in the center, you'll be fine there. All right, just make sure you go down 80 millimeters there as well as the question is asked. There's a lintel there, which I forgot to draw in. That means my block would actually go a little bit higher than that. We'll just move it up a small bit. And because we're going to be tight in space, we'll just go one block up and then we're going to go off with our rafter. So that's the wall on top. We can do DPC and things afterwards. Now, on top of the inner leaf, we have to draw a wall plate. It's a standard, traditionally cut roof. That's 75 by 100. Scale down 1:5. Your wall plate is basically just a length of wood that's nailed to the top of the wall, which allows you to nail your rafters into place. Now, the position of the rafter, we're going to go off at an angle here for the rafter. The question says the rafter is at 30 degrees. The roof is sloped at 30 degrees. And a mistake people are often making is putting the rafter up here, touching off the edge. The rafter must cut into the wall plate. All right, that rafter must cut through that joint. It's called a bird's mouth joint. So when you cut a notch out with the side of your rafter, it slots into the wall plate and then it's nailed into position. So with your 30 degree set square, you can go off down there like that. Just do it lightly first. Extend it on as far as you like. Extend it on up here for the moment. All right, now you can see there that's cutting into the block. Don't worry about that, because sometimes what they'll do is they'll just make the external leaf a block lower so it can go down. Sometimes they'll just cut a notch or a slot or hammer a slot out of that block so those rafters fit into place. That's not really a concern of yours, so you can just let that cut through there. That's no problem. Now, how far up does this rafter go? The question says, if you remember, the bay window extends 1500 millimeters out from the external wall. So if you get your calculator, at 1.5 meters, the question says, so that's 1500 millimeters. So 1500 millimeters divided by 5 is 300. All right, so you're going to go here, you're going to measure across 300. Okay, I'm going to just put it about here for the sake of the sketch, and that is where the external wall of the house will be. And that is how far the rafter will go. We'll come to that in a moment. We'll finish off this area and we'll come to that then, but we know the position there. Our standard rafter is 150 millimeters in size, so we'll just go out your 150 divided by 5, which is 30, and extend that off lightly. This is all done lightly first of all. Alright, now we'll do our soffit and fascia and gutter and all that first of all. The position of your soffit and fascia, that can vary. So just come out, you know, let it come out about that far. You decide. Draw your vertical line there. A little bit above the rafter here, a little bit below it. A fascia is 25 millimeters thick, and draw in a rectangular fascia. You can rub out that bit of the rafter now. Your soffit will come across like this, and that's 12 millimeters thick. Draw it across there, and even just put a vent in there. Size of the vent you can pick yourself as well. All right, and I'll just rub out that bit there as well, just so you can see. From there, we'll start doing some slates. Now you don't have to slate all the way across there, just 2 or 3 sets of slates will be fine. Sometimes they specify, this one hasn't, but we're going to draw those in anyway. Slates often cause trouble. Let's have a quick go at that. First of all, there's a little angle piece of wood just to support your first face. That's called your tilting fillet. A slate is roughly 700 millimeters long. So what I will do is, for the battens, half of 700 is 350. All right, so we're going to measure from this corner here up 350 and draw on your first batten. The batten is 50 by 35. So from here to here, 350, then extend on. I'll go back to the front of this batten and measure up 350 and extend on. I'll go back to this front of the batten here, measure up 350 and extend on. All right, so from here to here, 350. From here to here, 350. So it's like front to front is 350. All right, now for the first set of slates, we have to get a batten in the middle of this as well. So just measure in halfway and draw a batten in there as well, halfway. All right, so there's 3 sets of slates which will end up going over the front of that. So a quarter of a slate, don't even have to measure, just go from the center of that batten and extend the line out over the fascia there. Okay, that's the first slate. Ignore that, that's just a mistake. A half a slate then, so again 350. If you have to go above 350 just to get a little bit over the fascia, that'll be fine as well. All right, have it a nice thick line, have the tiniest of gaps there between those, the tiniest of gaps if you can, just so to show that's not one big smudge. Your first full slate from the center here, extend it on. Again, 700 millimeters, but if you have to go a little bit above 700 just to make it go past that batten, that'll be fine as well. And maybe one more full slate all the way across there like that. All right, and there's your slate. That takes a bit of practice too, because I know it's tricky to get right. That's that area there. Now moving on up here, oftentimes you have to draw a joist with a normal roof, and this kind of lean-to roof we've drawn in the past, there was a joist going across there. All right, now in this case the question says, if I can find it, into a roof, pitch 30 degrees, to form a sloped ceiling. All right, so the ceiling in this little lean-to, so if you're inside here, it's not got a flat ceiling. It says it forms a sloped ceiling. So if you were in this room, this little kind of sunroom or whatever it is, and you look up, the ceiling is not flat, it's sloped. So in this case, you don't need a joist. If you were to go and draw in a joist there, you know, the tiny marks would be lost, but you'd be wasting time drawing that in as well. So just make sure you watch these small details. It's actually a mistake I made when I was drawing this detail up as well. So it's a sloped ceiling, so just leave that as it is. We'll go up here, that rafter is fixed to the wall. We'll just draw the wall in here first again. So across your 100, across your 150, and across your 100. All right, again, this is a lean-to roof. It's a room that you can walk into. So it's got a sloped roof. So that wall is actually going to stop somewhere a little bit below there. You can decide how far down you go yourself. That wall stops there. Now, if that wall is stopping there, there's going to need to be a lintel. You can draw those into it. Again, if you forget to draw in that little section, or if you extend that wall down and just leave it, to be honest, there'll be no marks lost. It's only a minor detail that has to go into place. To fix a rafter to a wall, we have a length of wood. A wall plate that's nailed to this wall here, and that allows these rafters then to be nailed to that piece of wood there. All right, there's some blocks here we can draw as well. Not the most important thing in the world. Another detailed question I mentioned, it's a small thing, small few marks, again just to get your top marks on this. Insulated plasterboard is fixed to the underside of the rafters to form a sloped ceiling. Alright, it also says that the roof is well insulated. So there will be insulation between these rafters. Okay, I'm just going to rush that a little bit. There's an ease ventilator I forgot to draw in, which allows ventilation come up through here and not get blocked by the insulation. All right, and it says insulated plasterboard. So I've shown you before samples of insulated plasterboard. It doesn't say how thick it is, so let's just say for argument's sake it's 50 millimeters. So insulated plasterboard is like that rigid insulation with a layer of plasterboard on top of it so that you can plaster over it. And that's just fixed to the rafters, so it's extra insulated, so it's a well insulated roof now. All right, you've got your insulation between the rafters, you've got your rigid insulation that's nailed to the rafters underside, and there's plasterboard on that, and then you can plaster over there. All right, couple of little bits of pen work that are needed. There would be DPC here underneath that wall plate, so water can't rise up into that wood. There would be DPC above a window or door like this always. It goes across like that. There is felt, roofing felt runs all the way across, other than blue, the top of the rafters. Okay, and that's that. Now a little bit of detail work that needs to be included up here, and it's actually part B, the question it's asked for, is how do you prevent the ingress of water from getting in at the abutment area? This is the abutment area where the rafter butts into that wall there. So what happens is we have lead flashing. So lead is the first block above that. There's a lead in there. It's folded down here and down over the felt there. Okay, and then the tiles will come across up there, and the rain cannot get in there because there's tiles, there's slates, there's felt, and there's lead there as well. So you can put an arrow point into that there, which I'll show you there in the final solution. So again, bit of work involved in that one, but if you get down and do it, you find it's fairly straightforward. If you're to do it once, you should get through it well the second or third time. This is the final solution. You can see there I actually had to rub out my joist because I made a mistake trying it up, and there was no need for that. That's the window area. All right, fairly standard. The rafter goes all the way up at 30 degrees. You can see there that it slots into it goes through as the bird mouth joint there. That's the detailing up here. That is the wall plate. That's the wall up there. You can see the lead in red comes down, and then the felt extends up. You can see that in your books as well. I brought my slates all the way up there as well. If you want, you can. You don't really have to. All right, and part B is just labelled there: felt and lead flashing ensure there is no moisture penetration at the abutment. All right, so I'll just hold that above. You can see there's about 13 or 14 labels there as well, I think, just to cover your labelling of the whole thing.